In the topic formulae and variations, we have got formulas which involves making a term the subject of the formula. It usually involves making the term the subject of the formula. So to develop on this content, I'll start with the simplest examples as I go to the complex one. So stay to the end of the video so that you can see how we can develop from the simplest formulas to the most complex formulas. So for my example one, I'm going to take a simple formula such as A is equals to B plus C. For this, I'm going to make C the subject of the formula. For this, I am going to make C the subject of the formula. To make C the subject of the formula, I'm going to move C. I'm going to make C to be alone first, and it should be alone on the left-hand side of the equation. It should be on the left side of the equation, and this all other terms should be on the right hand of the equation. So A is equals to B plus C. I'm going to take C to the left hand side and I'm going to take A to the right hand side, so that C is positive here. If it goes to the left hand side, it is going to be negative. So it's going to be negative C is equals to B. A is positive, it moves. If it moves to the right hand side, it's going to be negative. So negative C is equals to B minus A. But remember, the goal is to make C the subject of the formula, not negative C. So I'm going to divide by negative 1 and all of these equations by negative 1. Or you can also multiply it by negative 1. You will get the same answer. So C is going to be equal to negative B plus A. In example 2, if you look at example 2, if you have equation of a line y is equals to mx plus c, and you are told to make x the subject of the formula, we are told to make x the subject of the formula. This is how we are going to go about it. We are going to take c to the left hand side of the equation, so we will have y minus c is equals to mx. The goal is to make x to be alone, and here x is attached to m, so we are going to divide by m. M cancels m, so we will have x is equals to y minus c all over m. If you have got another example such as A, this is my example 3. For my example 3, I have A is equals to the square root of BC all over D. A is equals to the square root of BC all over D. And we are told to make B the subject of the formula. To make B the subject of the formula, the first thing that you are supposed to do is to do away with the square root sign. And to do away with the square root sign, we are supposed to square both sides of the equations. So you are going to square the right hand side, and we are also going to square the left hand side. So we will have a squared is equals to BC all over D. We are done with the square root sign. The goal is to make B the subject of the formula, so we are supposed to make B to be alone. So to do away with the fraction, I'm going to multiply both sides of the equation by D. So D will cancel D. So if I multiply D by a squared, I'm going to get D a squared is equals to BC. I want B alone, so I'm going to divide by C. C cancel C, so I'll have B to be equals to D a squared all over C. For our last example, which says that make x the subject of the formula, and you are given the equation such as y is equals to bx all over the square root of cx squared minus a. You can take a moment, pause the video and try out the question, see if you can get it. Now, to solve it, y is equals to bx all over the square root of cx squared minus a. The first thing that you are supposed to do is to do away with the square root. And to do away with the square root, we are going to square both sides of the equation. That is the left hand side and the right hand side of this equation. So we are going to square this, and then we are also going to square y. So the result is going to be y squared is equals to, if we square bx, we are going to get b squared x squared all over. Now, if we square the square root of cx squared minus a, we are going to get cx squared minus a. We have done away with the square root sign. The next step that we are supposed to do is to turn the equation into linear. We are going to do away with the fraction part. And to do away with the fraction part, we are going to multiply both sides by cx squared minus a. So, cx squared and cx squared cancels. So, we will remain with, if we expand the left hand side, we are going to get y squared cx squared. That one I have multiplied y squared by cx squared minus y squared a. I have multiplied y squared by a is equals to b squared x squared, since these two have cancelled. Now, the next thing that we are supposed to do, we are supposed to take the variables or the part of the equation containing x and place them on one side, and the part of the equation that does not contain x, we place them on the other side. So I'll take b squared x squared and take it to the left hand side of the equation, and I'll take y squared minus y squared a, since it does not have x, and put it to the right hand side. So I'm going to have y squared cx squared is equals to, y squared cx squared minus b squared x squared is equals to y squared a. If we look at the left hand side of the equation, y squared cx squared minus b squared x squared, you can see that x is a common term. It is a common term, so we can factorize it outside. So we'll have x squared into y squared c minus b squared is equals to y squared a. I'll divide this by y squared c minus b squared, and also y squared c minus b squared, so that I can remain with x alone. So x squared is equals to y squared a all over y squared c minus b squared. Since I want the value for x and not x squared, so to mean that I'll take the square root of both sides, and this will give me x to be equal to the square root of y squared a all over y squared c minus b squared. That's it for the video. If you find the video informative, consider liking it, sharing it with your friends, and subscribing to our channel. Thank you.